let's understand the concept of center of mass and its role that it plays in stability with the help of an experiment
using balloon and marbles.
So first of all, we need to understand what is center of mass. The center of mass is the point at which the entire mass of a system or an object can be considered to be concentrated for the purpose of analyzing motion. So if we take symmetrical objects like a sphere, the center of mass lies exactly at the geometrical center. So also the case of cube. A cube is also a symmetrical object and the center of mass lies at the geometric center. And if you take a stick of uniform density, there also the center of mass will lie exactly at the center. Now we will understand if we'll have a uneven distribution of mass, that is a hammer. If we'll take a hammer, the mass distribution is uneven and you will find that the center of mass shifts towards the heavier part. And it is marked here as yellow dot. Now how to alter it? There are few methods through which we can alter the center of mass. The first one is adding or removing mass. Now you take a rod of uniform density. The center of mass will lie exactly at the center. You can see it in the form of a yellow dot. But if we'll add a curved portion with the rod, then you can see here the center of mass shifts towards the heavier part. Similarly, the second method we can understand, that is changing the shape and posture. In humans or animals, changing body positions like raising the arms, leaning, changes center of mass. You can see in the video a gymnast here trying to raise the hand, and in doing so, she adjusts the center of mass to balance on the beam. The third case we can understand is redistribution of mass inside the object. This is a very interesting one which is used by the engineers to design the cars, aircrafts and rockets by placing the components such that the center of mass is at the stable position. The fourth one you can understand by external attachments. So if you'll take an example of a crane here, a very heavy weight is attached. You can see here a very heavy weight is attached to counterbalance, and it deliberately shifts the center of mass for balance or better performance. Now we will understand how in daily life or real life we can do some experiments to understand the concept of center of mass, or we can say how we can shift the center of mass. Take a balloon, inflated balloon, which is very light, of course, and you try to adjust it in the upright position. You can see in the video it is never going to stay in the upright condition. It is always going to tip over. So why is it happening? If we'll go to the schematic diagram, if this circular one will be considered as a balloon, then the center of mass lies exactly at the geometrical center, which is lying at very high up from the tabletop and also has a very narrow bottom area. That's why the small disturbances make the vertical line from the center of mass fall outside the base area. Hence, the balloon is tipping over. So how to adjust it? Let's go the next video. So what we can do here, we will take some marbles and take a balloon.
Just take a marble, try to put it inside the balloon to alter the center of mass.
As you can see in the video, a small marble is already attached inside this balloon. Now, what happens? I'm just trying to displace the balloon from its position. You can see in the video that the balloon is just staying upright, keeping its position intact. So why is it happening? Now you can see in the schematic diagram, previously the sky one represents the balloon. I have attached the brighter navy blue color is the marble. So by attaching it, what happens? There is redistribution of mass. The center of mass shifts from the center of the balloon to the lower end, and it is much closer to the table. So what happens? Here if you want to displace the balloon is just maintaining its balance. Means we can say that it is in a stable equilibrium condition. So what can we conclude from this experiment? Balloon without marble, this is an example of unstable equilibrium. Why is it happening? Because it has a very high center of mass and a very small base support area. So it is easily toppling over. But in case of balloon attached with marble, even if the balloon slightly tilts, the vertical line of the center of mass is still inside the base area. So balloon returns upright. So this is an example of stable equilibrium. Here the restoring force is acting in such a manner that it is returning the balloon towards its equilibrium position. Now we can conclude here that what are the physics behind it? The stability of an object depends on the height of the center of mass. The lower the height of the center of mass, more stable will be the object. Similarly, if we have a larger base area, more stable will be the object. And if the vertical line of the center of mass within the base area, then also the object will be stable. So here in this video, we have added a marble to lower the center of mass to effectively anchor the system and making it stable. So now where it is used? It is used in daily life like punching bags and toys like roly-poly dolls, where this concept of center of mass is actually maintaining the stable equilibrium and making the system stand upright. I hope so this video has helped you in understanding the concept of center of mass. Thank you for watching. Stay tuned for the next video.